Okay. Could you talk about the technology itself? Like, is it some form of artificial intelligence, or are we using increased amounts of sensors? What's actually going into making this quite profound change possible?
It's actually surprisingly simple. We're basing it off stereoscopic optics
Hmm.
that have an attached brain to it. It is mostly on the software end. We are building out relative navigation capabilities and situation awareness based on having a pretty small, set of eyes and a brain on a satellite. So the basis for it are the bases for it are catalogs of objects in space where
Hmm.
they're supposed to be,
Hmm.
where they're propagated to be, just like we have on the ground, but which are tied into local situation awareness and perimeter kind of scanning. We verify and map what is around us,
Mm.
and we match those objects that we see with what's supposed to be there, and we provide much higher fidelity understanding of where those objects actually are, so that we can then kind of proactively act to avoid or get additional data on it compared to what we have from the ground. That can mean not only things that might crash to us, but things which might crash into each other.
Hmm.
So it can be not only just a two-body problem, but a three-body problem or four-body problem where we can see and validate and verify things like formation flying,
Yeah.
just like we can do it right now to look at a couple things in the sky and see how they're acting against each other. Well, a stereo camera system can provide a whole additional dimension by fundamentally than what we can just by supposedly knowing where they are.
Right. So I think I mentioned this to you before the recording, but to anybody outside of the space industry, it sounds a little bit crazy that this hasn't been implemented kind of when the satellites were being launched. When you think of space, you think high tech, but I think you mentioned that that is certainly not the case. And yeah, I mean, I'm just going to repeat myself. It really sounds crazy that that this almost like fundamental functionality of these satellites hasn't been around for a decade or more.
It's funny because you would think that, oh my gosh, I can't believe that we just don't have like collision avoidance instituted,
Hmm.
oh
Hmm.
yes, it's just in a trajectory in space, like we should know where things are going to be. But honestly, it actually is harder than you'd think. We have different challenges in automating or predicting motion on
Hmm.
the ground, in the air, on water, and in space than we would think to initially. The biggest issues on the ground are uncertainty about the human condition, or uncertainty about what things are supposed to look like versus what they actually look like,
Yeah.
managing things like decay and deterioration of objects. How can we follow um, traffic markers that might be covered with graffiti, or humans that do really really dumb things all the time as an auto as a self-driving car.
Hmm. Hmm.
In space it's a little bit I wouldn't call it the opposite, but it's a matter of a lot of hardware limitations.
Hmm.
The systems that we fly in orbit are resilient, and it's really really tough to affordably create a resilient system that also can do things like uh, deep learning and physically informed machine learning processes, and integrating huge swaths of data into situational awareness knowledge. It
Hmm.
is a non-trivial problem that we've only seen resolved at scale, um, you know, in the last 5 to 10 years,
Right.
and deployed in things like small satellites, getting computational power and even relative navigation in small satellites. That's been a 5 years ish kind of timeline problem. We have not actually been able to do this stuff as a
Hmm.
baseline until very recently. Um, you might think, oh, we've been doing docking since the 60s. Yeah, one docking every couple of months that is, you know, millions and millions of dollars of cost,
Right.
because we have to like go through every single bit. I joked a little bit about how over designed things are in space.
Mhm.
I mean, yeah, what's the consequence of not over designing it? So we're at the point where there's now a bit of a smaller delta, a smaller barrier of entry for over design, and that's part of why it's only now really viable to start doing these things.
Very interesting. Yeah, it makes perfect sense. Um,
Space is hard isn't just a meme. It
yeah.
it, it is really it's more of a philosophy. It's really more of a reality that you have to kind of come to terms with, honestly. Like,
Hmm. Hmm.
oh, this is really hard. Oh, it's weird to think about. Like, of course, space is hard, but
Yeah.
the variables that you have to kind of like really get through each other's skulls when you're in an engineering discussion about this, um, they have nothing to do with anything. Like, you have to discuss so much stuff that has nothing to do with what you're doing, in considerations, in things like coatings, in things like material selections, and things like you know, risk mitigation processes, and things like orientation of the spacecraft,
Mm.
and things like propellant use, things that people just don't solve until you have to, because this is entirely new.
Right.
There's a lot of different examples I can cite, that I think are funny, about things like, oh hey, we noticed that this satellite died or started dying really quickly all of a sudden. What happened? Oh, you know, when we look through the solar panel responses, hey, there's like a lot, there seems to be like, is this molybdenum? There's a lot of molybdenum on the solar panels or something. That's that kind of matches. Oh, it turns out that our thruster has been eroding the grids on the on itself with the propellant, and now there's a bunch of molybdenum just in a cloud around our satellite every time we thrust, and it's coating our
Crazy.
solar panels because we're space charged.
Yeah.
What
how would you
what
possibly think about that beforehand, right?
And it's still something that people don't even think about today.
Yeah.
How do
Yeah.
we manage backflow in a satellite flight scenario?
Mm.
People don't think about it. I've actually spoken to a lot of people about it that should know better, but it's fine. Like, should know better
Yeah.
is maybe that whole diatribe is probably not a good one to include, but that situations like, will my thruster accidentally coat my satellite with dangerous propellant material or eroded grid material from our
Hmm.
thruster, just tearing up the actual housing that it's in, and potentially short out a bunch of things, is something that we've been seeing since the 60s and 70s, but which we have to keep learning again and again. And people are still doing theses on, people are still like discovering new methods and doing studies
Mm.
of that kind of degradation on an ongoing basis, because we are working with very, very tight margins and very weird failure scenarios and modes.